Alright guys, welcome to my channel. Um Starstruck Rambler here again. I've been a bit quiet lately, but I'm back. Um with my newest video, Planetary Formation. Now what we're gonna talk about a bit is as the name of the title of this video said, and just as I said before, we're gonna talk a bit about planetary formation. Now, planets form when clouds of gas and dust, nebula. I will show you just now a nebula, when part of a nebula collapses, it starts forming a protoplanetary disk, as you can see here. What happens is, when a planetary nebula collapses, the trigger can be, for example, a nearby supernova, for example, and this causes the nebula to become denser, or the shock wave from the nebula from the supernova compresses part of the nebula, and when certain areas of the nebula become denser, gravity starts taking over, and these denser knots of gas and dust then collapse further under gravity, and over hundreds of thousands or millions of years, this gas and dust keeps on collapsing, and it starts getting a spin on. It's basically like a ice skater throwing her arms in and starts to spin faster. The same with a planetary nebula. The denser or protoplanetary disk, in this case, the smaller it gets, the faster it spins. Now this is gonna be a bit slow, but my computer can't handle this many objects at one time, but as you can see, this protoplanetary disk has a pretty much wide range of material, ranging from hydrogen, helium, silicate particles, metals, water. Now, depending on the distance, just wanted to turn on the habitable zone quickly, just to give you a bit of a comparison. Now, just want to put this on pause. Now, any planets forming in the red and green zones would be rocky planets. Wait, scratch that. In the planets forming in the red, green and blue zones would be Well, most planets would be rocky planets because the temperatures in these zones would be too high for ice particles. Um, Most of the material in these free zones would condenses as solid silicate and metallic particles. Um, what's the word? They ugh. Well, anyway, I can't come up with the name right now, but basically the temperatures in the red, green, and blue zones is too high for ice to form. However, further out, beyond the blue zone, the temperatures are low enough for ice to form. Hydrogen, water, ammonia, methane, they basically freeze into ice particles, and because of disturbances within the disk itself, there are, well, according to the latest theories and evidence that we have so far, these denser areas would, well, basically they collapse under their own gravity, and they also draw in a lot of hydrogen ices and gas, forming large planets like Jupiter, Saturn, Uranus, Neptune. Just want to see if there are any. No. Just want to add a few planets. Now, these gas planets like Jupiter, Saturn, Uranus, and Neptune, they will form pretty quickly, in about 100,000 years or so. Now, in a report I read a few weeks ago, Jupiter is the oldest planet within our solar system, because I can't remember the exact dating method that they used, but the Juno probe that's orbiting Jupiter right now has found evidence that Jupiter is basically the first planet that had formed out of this disk. We're not exactly sure yet how it could have formed this fast, but an idea is that like I said before, some kind of gravitational instability came up in that area, and part of a dense area of the solar nebula or disk in that area collapsed, and its gravity drew in more material, and it became part of the forming planet. And the more massive this protoplanet became, the more gravity it had, and the more material it sucked in, and so on, forming a positive feedback loop. More material, more gravity, more material coming in, increasing the gravity, and thus creating a massive planet very quickly. Probably within 1 or 2 orbits around the sun. Yeah, I just hope the game now doesn't crash. And I think we just, not sure, but come on. Come on. What on earth? Come on, I want to see more. I want to try and... Okay, I think... Maybe not, I'm not sure, but let me just turn this off. Yeah, planetary. Yeah, I think okay, I'm a bit lost now. Yeah, I think this animation just is a bit slow now, slower. But planetary formation, as far as we can tell, is actually pretty common. Because we found a lot of these solar nebulas around other stars, and for example, Fomalhaut, around the star Fomalhaut, there's this planet that they discovered, and not sure if it's an actual planet yet. We're still doing research with that, and because we're not sure if it's an actual planet or just a dense part of the nebula. Just wanted to... Okay, and yeah, I think we just made a yeah, we just made a gas planet. We just made a gas giant here in this part of the disk. Okay, normally these kinds of normally this kind of gas giants or gas planets don't form this close to their host stars, but like I said in a previous video, sometimes planets migrate, and we have found gas giant planets very close to their host stars. Let me just start a new animation and show what I'm trying to say. And let's just pick any star. Let's say this one, and let's take Jupiter. Now, Jupiter is about just over 5 astronomical units from our sun, or about almost 5 times further away from the sun than the Earth is, at 750 million kilometers normally, which is about this size. I haven't checked it. Wait, let me just check here. I mean, you go away. Just want to make sure exactly. Um. Yeah. About. Yeah. About. Yeah. About this distance. However, some large planets are actually much closer than this. We'll just leave this one in, but because of planetary migration, they actually slowly migrate inwards like this. Okay, it's actually more of a spiral that they do, but I just wanted to show you guys what it would more or less look like. Okay, let's just speed it up a bit. Okay. Yeah, it just keeps spiraling inwards until it's just a few million or so kilometers from the host star. Okay, it's actually much closer. As in way closer. I just hope it doesn't get torn apart because of tidal stresses. But yeah, some of these gas planets are so close to their stars, host stars, that they basically just orbit the stars in just a few days or even hours. Let me see if I can get it even closer. Ooh, I just hope this doesn't tear the planet apart. I hope not. Seriously, I hope not. Yeah. Okay. But this is what it would more or less look like if a Jupiter-sized planet were to orbit a star much closer than normal. Yeah, normally these gas planets are 5 or more astronomical units away from the host star. Now the furthest planet that we know of from a star is way further than this. So let's go in the opposite direction, which would be, let me just, okay, so yeah, just give it a few minutes, and okay, I just want to do that as well. So yeah, there's this one planet that's orbiting a star way beyond the normal orbits of planets, about a light year or so from the star, which is highly unusual. And we're almost there. Almost. Yeah, and we're there. Whoa. Yeah, but basically this planet is extremely far from its parent star. How it got there, we have absolutely no idea of how it managed to get that far from its star. Okay, planetary migration might be a plausible idea, but even that just can't explain properly how it could have gotten that far from its star. Yeah, we're still doing research on that of how it could have gotten there in the first place, but yeah, this planet has a highly unusual orbit. We just have, okay, what is this? Oh. Yeah, we just have no idea of what happened there, of how it could have possibly gotten there in the first place. Yeah, but that's about it for now. Just wanted to talk a little bit about planetary formation and migration a little bit. Yeah, it's a bit off center since I haven't made a video in a while, so I'm a little rusty. But I'll talk more about planetary formation and migration in later videos as I progress with my channel here. Yeah, just keep it coming with the requests, and okay, I haven't had any requests or anything, but yeah, I'll just keep this channel going as long as I can, and we'll see what happens with this channel. I actually enjoy this now. Yeah, but let's end this video with a bang, just for the fun of it, and boom. Okay, nothing, okay, we're not gonna see anything immediately because it's gonna take some time, but let me just speed it up a little bit. Yeah, this is yeah, and you guys, oh yeah, supernova. Oh yeah, I forgot about the supernova. Yeah, basically, when a star, let me just add Angel here. Go away. Oh man. Let me try that again. When a star, like Rigel over here, get to the end of their lives, large stars like Rigel over here, when they, yeah, stars like our sun, they end up as planetary nebula. Okay, a planetary nebula is not like okay, I know it says in the name planetary as in planets, but a planetary nebula that forms from a star has nothing to do with the kind of nebula that I talked about earlier in this video. Okay, basically a sun-like star puffs out its outer layers, forming this planetary nebula and leaving a white dwarf behind. However, larger planets like Rigel over here, when they reach the end of their lives, they basically they explode as supernova, leaving behind yeah, they either leave a, let me just quickly go out here a bit. Yeah, they either leave behind a neutron star like this over here, PSR 1919 plus 21. Yeah, they have a mass of between 1 and 3 suns, and they are extremely tiny. This one is just 11.5. It has a radius of 11.5 kilometers, so it's basically 23 kilometers across, which is extremely small. Yeah, where's a, okay, where is as a comparison, this object next to the white dwarf here is Halley's Comet. Yeah, that's right. This little object, this one here, high, is Halley's Comet. And as you can see, this neutron star is just a bit bigger than, just a little bit bigger than Halley's Comet over here. Now the other thing that results from a supernova, you should be able, where is it now? I think we lost, go away. Man, where is it now? Okay, I think we just lost the supernova, but anyway, the other thing that comes from a supernova is a black hole. Let me just take a big one. Just pause it and let's go there. As you can see, this is a black hole, and as you can see, well, nothing in this case. You can't see a black hole. Okay, against a black backdrop like this, you can't see a black hole, but if you go in front of a brighter area like over here, you can actually start seeing it, how it bends the light over here at the edges because of its intense gravity. Now I will talk about this kind of stuff in a later video. So until then, please be patient with me, and I'll see you guys in another video. Wonderful people. So until then, cheerios.